Let's have an overview of data mining. Data mining is not an isolated area of study. It is highly related to many others under the big umbrella of big data and data science. So let's talk about it in the context of these terms. In 2011, the McKinsey report observed the increasing importance of big data as the scale, distribution, diversity, and the timeliness of data that requires the use of new technology and the type of analytics to enable insight that can unlock new business value. And very important in that report, it was predicted that there would be a shortage of talent necessary for organizations to take advantage of big data. The McKinsey report has had a major impact on the evolution of related fields. Since the report, there has been a very rapid growth in the number of industrial positions and academic programs motivated by the term big data. This is certainly not a fad purely driven by a report. They have been driven by real challenges and opportunities due to data. In particular, the V's explain why data are both challenging but potentially rewarding as well. Look at the sheer volumes of data that we generate and consume. The variety of them in so many different forms and formats, and the velocity or speed at which they arrive and depart. Is that fascinating? Or perhaps a bit intimidating for those of us who want to get hold of them? Besides, it is also the time of fake news, right? So what value do your data provide? Perhaps it does not mean a lot in its raw forms, but what about your analysis? Can you actually identify truthful insight and add important value to the data that you have? These are critical questions. Questions that cannot be answered with a narrow mind, but should be tackled by a joint effort through collaboration. That's why related approaches to these challenges do not come from a single discipline, but many. And these include computer science and information sciences, machine learning and AI, as well as methods from statistics, data mining, information retrieval, and many others under the umbrella of data science. So let's talk about data science. And this is the definition of data science that I think is broad enough. So according to this definition, data science is an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insight from many structural and unstructured data. So data science is the big umbrella term that covers a wide spectrum of scientific disciplines. And there has been an evolution from traditional business intelligence to today's notion of data science. From the focus of highly structured data, even relational data, to unstructured data such as text, images, and human languages. From ad hoc reporting that is driven by human executives to predictive modeling that is driven by data. Now our focus has shifted from basic statistics and hypothesis tests to answering more complex contextual questions. Some refer to this as the evolution from analytics 1.0, which is focused on business intelligence, where data is secondary, to analytics 2.0, where big data is the turning point, and to analytics 3.0 of the data economy, where the business is about the data, or data are the business. This represents a paradigm shift. As Jim Gray suggests for scientific discovery, data is the fourth paradigm. Over the history of science, we have evolved from the paradigm of empirical description to theoretical generalization to computational modeling, and now to a new paradigm based on data exploration. So what's data mining? Data mining is well suited for this paradigm shift. In fact, from the beginning, it was designed for this new paradigm. In classic statistics, for example, you were to come up with a hypothesis independent of data and only use the data to find out whether your hypothesis is true or false. You were not supposed to fish potential hypotheses by mining the data. In today's paradigm of the data, however, there have been applications where the pure objective is to mine, generate, and validate hypotheses. IBM's Watson's participation in the Jeopardy is such an example of text search and mining to be able to answer human questions. Constructing hypotheses is one way to represent human knowledge in a true versus false statement. According to Hahn and Michelin in 2011, data mining is the extraction of interesting patterns or knowledge from a huge amount of data. Interesting meaning it is non-trivial, implicit perhaps, previously unknown, and potentially useful. In essence, this is to discover insight and knowledge from data. Data mining is often referred to as KDD, or knowledge discovery from data. There have been lots of alternative names, such as knowledge extraction, data pattern analysis, data archaeology, data dredging, information harvesting, business intelligence, and so forth. Data mining is an important field in data science because of its objective for knowledge or insight. And data science, the key here is really about science. And by definition, science is the acquisition of knowledge. So data mining is well aligned with the notion of data science. And it is associated with many fields such as statistics, machine learning, information retrieval, natural language processing, among others. Overall, a data science project involves such steps as data cleaning, integration, selection, transformation, mining, evaluation of the patterns, and then finally, knowledge representation. So the actual mining is only part of a big picture, and this can be a life cycle that repeats itself because oftentimes it takes multiple iterations to get to the pattern that you hope to identify. So it is important to recognize the importance of each step depending on the data and objectives. This is a life cycle of multiple iterations until useful insight can be drawn from data. And so it may require different expertise and domain knowledge to guide the process and interpret discovered patterns or knowledge. Many types of data can be treated as an input for data mining. Your data may be structured relational data or unstructured text data. Static are structural data or temporal time series, homogeneous data or heterogeneous data from different sources collected perhaps from the web. The output of data mining is knowledge representation. That is the insight or patterns discovered from data. It can be aggregation or generalization of data, identification of frequent patterns or association rules, discovery of major patterns and themes as clusters, or a trained classification model that can make predictions or decisions. These are ones related to major styles of machine learning. However, data mining is not limited to these. There can be other patterns that you hope to identify, such as the detection of outliers or exceptions, certain trends and evolution, some characteristics of a graph or network, and so on. So there are lots of potentials, and data mining is an exciting field with all these potentials.